Hey guys, we're looking at 3 merit questions today from 2014. This question here was very similar to the one we did a couple of days ago. Just I wanted to keep up with the theme of just getting rid of square roots. So if you're going to get rid of square root, it's always a good idea to have one side, either the left-hand side or the right-hand side, to be with the square root. Okay. So for example, in this question, if you decide to say this is what the equation is, and you decide to square this, you're going to end up with like a really ugly long equation. All right. So one of the first things you really need to do in this question is rearrange things so it makes it a bit easy. So the first thing I'm going to do is I'm going to get rid of the 3. I'm going to bring it to the right side, and I'm going to make it x minus 3 equals square root of 33 minus 4x. Now once I get to this spot, then it's actually a lot easier to actually square and get rid of the squared symbols. So I can square this, and if I square this, I should be able to get rid of the square root symbol. So when I do this, what ends up happening is I get x minus 3 squared equals square root and squared is gone. So I've got 33 minus 4x. So now it's just a matter of expanding, rearranging, putting it equal to 0, and solving. So when I expand the right hand side, I get x squared minus 6x plus 9 equals 33 minus 4x. Simplifying this, I get x squared minus 2x minus 24, and that equals to 0. Okay, so from here I can say that I get x minus 6, x plus 4 equals to 0. Therefore x is equal to positive 6 or negative 4. Okay, is that all right so far? Now, are we actually finished with this question? Does it look finished? Kaylee's saying yes. What do you think, Rashmi? Finished with this question? You would think so, right? Because you got nice 2 little answers. You're like, yeah, I think I got this sorted. This is a nice merit question. I'm going to burst your bubble and say this only gets you an achieved. Now you want to know why? You want to know why? You got to take these numbers and you got to put them in here and see whether they actually work out. All right? For example, if I take x is equal to 6 and I substitute x equals 6 in this equation, because I have the equation x equals square root of 33 minus 4x plus 3. If I substitute x as 6, I should get 6 is equal to 33 minus 4 times 6. Have I got this right so far? Plus 3. So then 6 is equal to square root of 33 minus 24 plus 3. And I get 6 equals square root of 9 plus 3. And square root of 9 is 3. So this side, it matches up. However, if I put x equals to negative 4, see what happens. I've got negative 4 on one side and square root of 33 minus 4 times minus 4 plus 3. Is that okay what I've done there? So simplifying this, I'm going to have 33 minus 4 times minus 4 is 16, positive 16. So positive 16 plus 33 is 49. Okay, and as you can see straight away, square root of 49 plus 3 is not going to equal minus 4. So therefore in this question you only have one solution, which is x equal to 6. So you can't actually have x equals minus 4. So just whenever you see the square root solutions, always think about it. You got to go back, substitute the values, and see if they actually work out, because there's a good chance one of them is not going to work out. Questions on that? I bet everybody put x equals to 6 and negative 4. Am I correct? Yeah?
got so happy.
All right, should we go to the next question? Any questions on this? Okay, next question. So with this question, what they're asking us is find the x value at which the tangent to the function is parallel to x-axis. Now I think we did this maybe last week or the week before that. If it, oh, thank you, Kunsh. Appreciate that. What does it mean by parallel to the axis? What is the gradient equal? 0. So I think that's the key thing to notice here. So we're basically asked to find when the gradient is equal to 0. So our function is, I'm going to put that as f of x. So we got f of x equals 4 e to the power of 2x minus 2 plus 8x. Now, looking at this, there is, how do you guys actually do this? Oh, yep. So what'd you get it as?
4e minus 2x plus 2.
Sweet. So just remember when you bring when you bring something from the denominator to the numerator, the powers, they actually change symbols. So that's all that's happened here. So when I differentiate this,
Minus 8e to the power of the same thing. So
he's on fire, isn't he? All right, so write everything as it is. And of course, this, because it's exponential, we multiply by the differentiation of that, which is negative 2. And of course, differentiation of plus 8x is just 8. Okay? Now, because we said the gradient is actually equal to 0, we can say 0 equals negative 8e, negative 2x plus 2 plus 8. Rearrange this. So I get 8 equals e to the power of negative 2x plus 2 equals positive 8, which means e to the power of negative 2x plus 2 equals 1. Okay? Now, just remember this. I mean, if from here, I'm going to show you guys a really quick thing to do. Anything to the power of 0 is 1. Do you guys remember that? So then I can rewrite this as e to the power of negative 2x plus 2 equals e to the power of 0. So because of that, what I can then say is whatever the index power here is actually going to equal the index power on this right-hand side. So I can straight away just write negative 2x plus 2 equals 0. Rearranging this, I'm going to get negative 2x equals minus 2. X equals minus 2 divided by minus 2, which equals positive 1. So in terms of merit, this is your merit. In terms of achieved, just your differentiation, which is you're achieved. We're good? Questions? Should we go to the next question? Okay. Okay, so what they're actually asking us is, in this question, they're asking you to figure out what k is. Okay? The second thing, the clue for you is areas A and B are equal. Okay? So that means whatever this red area is equal to whatever the light blue area is. Now what you can do is have a look in the question. Can you actually figure out what this area is going to be, the green part, which is the whole thing? See, if you work out what the green area is, and if you divide it by 2, then you can actually get what area of A and B are. So your first objective is to try and figure out what the green area is. And to do that, we've got our two limits, which is pi and 0. We've got our function here as well. So we can write it up as between pi and 0, we're looking for integration of sine x over 2 dx. Do you guys want some time to work on this first? Have you already done it? Okay, I'll tell you what, I'll give you guys a couple of minutes, just have a go by yourself, and then I'll continue on this. So basically we need to integrate this. Integrating this, I'm going to get negative cos x over 2 and divided by differentiation of whatever's in the bracket, which is 1 over 2. Alright, and this whole thing is between pi and 0. So I can rearrange this as negative 2 cos x over 2 between pi and 0. Is that okay so far? Okay, when I substitute this, I'm going to have negative 2 cos pi over 2 minus negative 2 cos 0 over 2. Cos of pi over 2 is... Yes, of course it's positive 1. We know it's above the x-axis, right? So cos of pi over 2 was 0. So that's 0 minus 2. Cos of 0 is 1. And there we go. So we got 0 plus 2. So the area, the green area, is equal to 2. So if the green area is 2, what's the red area? 1. Fantastic. We can do 2 divided by 1. Okay, so to figure this, now, is it better to use between pi and k or k and 0? Yeah, because 0 is like nicely eliminated, right? Do we need to integrate again? No, because we already know what the function is. So we can literally write like this. We have negative 2 cos x over 2 between k and 0 equals 1. Okay, so basically all we need to do is we just need to solve this. So we have negative 2 cos k over 2 minus negative 2 cos 0 over 2 equals 1. Is that okay, what I've done there? So rearranging this, negative 2 cos k over 2, and I know that cos of 0 over 2 is just 0, not 0, 1. So I have plus 2 equals 1. Okay, rushing through this, k over 2 equals negative 1. So cos of k over 2 equals 1 over 2. Is that all right? So at this point, you guys can actually just use your calculator. You can work out that k over 2 is inverse cos of a half. So k over 2 equals pi over 3. And finally, k is equal to 2 pi over 3. Right? Merit. And for achieve correct total area with correct integral. So if you get up to here, that's an achieved. How do I get pi over 3? Look at the special triangles. That's how you get it real quickly. Otherwise, you get a decimal point in your calculator. But you guys do get given special triangles in the exam. So, okay. Any questions, folks? That's it for this session. Thank you for watching.